Orca series smart linear motors have 5 modes of operation: sleep mode, force mode, position mode, haptic mode, and kinematic mode. Today, we will show you how to get started with haptic mode, which combines position, velocity, and force to model physical behaviors, such as spring simulations, oscillations, damping, and more. Haptic mode is useful across a wide range of applications, such as medical training, simulating mechanical characteristics for testing and measurement, simulation, and robotics. Orca motors are fully integrated. All drivers, controllers, and sensors needed to run your motor are located inside the motor's chassis. To enter haptic mode, select the Force/Haptics page in IrisControls. This page allows you to enable and configure the desired set of effects. To enable a haptic effect, click the Enable button next to the effect. Then, when you click Enable Haptics, the selected effects will become active. You can click Save Configuration to save your selected effects and configurations to permanent memory. Constant force. Just like it sounds, this will output a constant force. You can input a desired force in millinewtons in either a positive or negative direction. A filter strength parameter is also provided in order to smooth new inputs. When using haptic mode over Modbus, increasing the filter strength can help reduce abrupt movements by smoothing out large changes in input. Springs. The spring function enables the motor shaft to simulate a spring effect. This function has multiple tunable parameters in IrisControls. Gain allows you to tune how many newtons the motor will output per millimeter of displacement from its center. The center of the spring is also programmable. The dead zone is a range around the center where the spring won't take effect. Saturation, measured in newtons, is the maximum amount of force the spring can output. If set to 0, there is no limit. Coupling dictates the axes that the spring will function in. Positive and negative allows it to spring both ways, whereas negative only or positive only limits the spring action to their respective directions. The damper function outputs force negatively proportional to the speed of the shaft. That means the harder the motor is pushed, the harder it will resist. The damper strength can be tuned by changing the amount of gain. Inertia acts on the acceleration of the shaft, depending on the amount of gain set by the user, giving you more control over the movement and resistance of the shaft. Oscillation. The oscillators output force waveforms. The amplitude is the peak force of the waves, and frequency is the rate they will oscillate. Oscillations can operate with sine, sawtooth, triangle, and pulse waveforms. For pulse waveforms, the duty cycle is configurable. The duty cycle dictates how often the signal is high for each period of the waveform. All of the haptic effects are fully configurable by the user, and can even be layered for unique and specialized profiles. Haptic mode is fully controllable over serial connection, and as all the control is done locally within the motor, there's no external communication latency, which enables a 3 kHz control loop. For more short video tutorials, visit our IrisTutorials webpage, or contact our team for further assistance.